Assalamualaikum warahmatullahi wabarakatuh. We are from Group 10 of Integrated Design Project. We are assigned to build an e-bike transportation system in IIUM. The problems that happen around IIUM gave us inspiration to build such a system which it can, first, reduce traffic congestion within the compound, second, provide easy means transportation between facilities on a personal case, third, to complement the existing shuttle bus system in the university, fourth, to inculcate the use of environmental friendly means of transportation. Thus, we had created a small, compact, viable, modular conversion kit that can be mounted on any types of bicycle along with various charging stations to be situated around IIUM.
Assalamualaikum. My name is Aiman, one of the group member in this electronic bicycle project for our IDP. Today, now I will talk about the design of this bicycle. The design we make is very simple and easy to apply to a bicycle. Firstly, we put the motor and the rotator in front because of what? Because if we put at the back, it will disturb the momentum of the user to cycling. Then we connect it to the battery at the back. The reason why we put at the back because it's very easy to the carrier to put to support the bicycle, to support the battery at the back. Then we connect it to the motor 40 ampere motor controller and in front. The reason why we put here because easy to the user to open and off this motor. Then this is the design of our project. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rizal bin Abdul. I am one of the group members in electric bikes. I will explain about the movement of the robot. Please come close. Here, this is the PW controller which controls the DC motor that we locate here. The reason we locate the DC motor in front of the wheel is because it is easy to be placed by the people who are not very familiar with the mechanical works. So normal people can also place this DC motor in front of their normal bikes. As we can see here, near here, when I turn on this PWM controller, which is here, this one, if I control this slowly, turn on, and then I rotate, and then this one also will rotate. The small wheel will rotate, and also makes this bigger wheel to rotate as well. As I increase this bigger wheel will rotate even faster. To move these bigger wheels, at first we have to start manually. After we cycle manually, and then we need to turn on this PWM controller so that we can keep the momentum, keep going in front. But when reaching small hills, it faces a little bit push from our pedaling so that it can move forward. I think this is very good product that can be used in IIUM, so that students also can be used in IIUM. That's all.
Assalamualaikum warahmatullahi wabarakatuh. I am Hanif bin Anwar, representing the Group 10 for Integrated Design Project presentation based on IIUM e-bike transportation system. Okay, the motivation behind this project is that we are trying to mitigate the problem of traffic congestion in IIUM. This is caused by the overusage of cars in the past recent years. So we are deciding on making a modular conversion kit for your typical bicycle. Okay, this is the technicalities and consideration for this system. As the name say that the modular conversion kit is to be applied to various type and range of typical bicycle possessed by the student and the staff. Okay. Um, as you can see here, this is the very rough sketch of a bicycle, of a typical bicycle. So we are planning to do a conversion kit that allows the user to attach the said kit on the bicycle to make it runs on electricity. Okay. Okay, moving on, this is the main idea for the project. The first one is obviously constructing the modular conversion kit, and the second one is the charging station for the conversion kit, because we don't want for the conversion kit to be run off the electricity for the supply, of course. Okay. Probably the made up of the conversion kit. The first main driving component here is obviously the electric motor. This electric motor is sufficient in driving the bicycle because the typical power needed for bicycle is around 100 watts, and this motor here can provide around 350 watts of power, which is enough for the environment in IIUM. Okay, so attached to the motor itself is the friction driver component, because we are trying to do a conversion kit that does not involve the mechanical complexity that will make the user and the staff to do a really complicated task of assembling the kit. Then moving on, for the speed controller, we are actually implementing an electronic speed controller that can control the speed of the motor itself by using the PWM method, pulse width modulation. Okay, and finally, powering up all the system is two 12-volt batteries that is sufficient enough to provide the motor with power that is needed for the bicycle to run on itself, on its own, on the user's discretion. And finally, for the charging station configuration, we are actually using just as a standard charging adapter for batteries that is compatible with the Malaysian outlet of 240 volts. So yeah, I guess that's it about our conversion kit. So thank you for listening.